Math!
Hello, this is Mr. Regner, and welcome to yet another exciting edition of The Aftermath. Today's focus will be focus. Specifically, we're looking today at Week 4, Focus Day 2 activity. Now, of course, this is great to review if you've missed something in class, but it's also great to review even if you were there, just to make sure that you understand how each of these problems can be solved mathematically. So, with all that being said, let's take a look at our first question. Question 1, multiple choice. Emma has 8 ribbons that are 7 feet long. Which equation shows how to find the total length in feet of all the ribbons put together? So for this question, it's one that you may be able to work out just inside your brain, just thinking it through. Think about what the question is really saying. Imagine Emma. She's sitting there, she has her ribbon. How much does she have in all? Now, a lot of you automatically know what operation we're going to use, but of course, we need to show our thinking and show our work in order to get that point for showing our work. So let's go to the head of our page here and see how this can all be written out for us. All right, so here is number 1, and there's 8 ribbons that are 7 feet long. I could draw out 8 ribbons that are all 7 feet long if I want to, but I know if I'm trying to find the total length in feet of all the ribbons put together, that means there's going to be 8 ribbons 7 times. So I could do 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8. And I think I got 7. 1, 2, 3, 4, 5, 6, 7. But of course we know if we're doing all of that, we might as well just take 8 times 7. Okay, so in this one, we need to examine all of our options for A, B, C, D. So letter A says 8 times 7 equals 56. Well, that's a fact that I know. 8 times 7 is 56. And it just so happens that's what I wrote out right here. So I'm going to go ahead and underline that one, not totally circle it yet, because I want to look at my other options just to be sure. So here's letter B. 8 plus 7 equals 15. Well, think about it. There's 8 ribbons. Each one is 7 feet long. They're not saying there's 2 ribbons, one's 8 feet, one's 7 feet. So 8 plus 7 equals 15, I'm sorry, is not going to work. How about letter C? We have 8 divided by 7 equals 1 1/8. The fact is correct. That is a true mathematical statement. However, we're not dividing today. It's not like she has an 8-foot ribbon that she's cutting into 7 pieces or anything like that. We're not dividing, so we can't say that it's C, and for the same reason, we can't say that it's D. So letter A, we can now circle it all the way because letter A is correct for number 1. So again, for number 1, make sure you're getting all of your points. Don't just answer by circling one of the letters, but instead show your thinking. Somehow, some way, show what's inside that brain and show your thinking by putting your work down on paper. Let's go ahead and move on to number 2. Number 2 says, constructed response. The table shows 3 different ways that toy animals are packaged at a factory. One bag of toy animals weighs 9 ounces. What is the total weight in ounces of the bags of toy animals in one crate? Now this is a classic question where they almost give you a little too much information. Some of the information we won't need to use, and we call that a distractor. Don't let a distractor distract you. Instead, identify it and then remove it from the problem so you won't be thrown off by it by any means. Let's take a look at the problem and do some work. So we have our package type. We have bags, we have boxes, and crates. And we know that inside each bag is 35 toy animals. Inside each box is 52 bags, and inside each crate is 14 boxes. All of that information is told for us right here as well in the picture. So that's all fine and dandy. But the problem tells us that the bag of animals weighs 9 ounces. And then we want to know in ounces the total weight of a crate. Okay, if we're worried about the weight, it doesn't matter how many toy animals are in the bag. So I'm going to go ahead and cross off 35 toy animals, and I'll do the same thing over here because 35 is a distractor. If I start thinking that I need 35 somehow in there, it's going to throw off my math and throw off my answer. So 35 is unnecessary. However, I do need to know that each bag weighs 9 ounces. That's going to be important. And on this question, we're sort of doing a two-step problem. We're going to have to do the math in order to do the math. So let's take a look. We have 9 ounces in one bag. That means that in a box there's 52 bags, so it's 9 times 52. I'm going to go ahead and write that problem out here and then do the math to figure it out. So 9 times 2 is 18, carry the 1 up top. 9 times 5 is 45, plus 1 is 46. That means that inside of a box, we don't care about the bags, each box is 468 ounces. And again, I could write that over here as well. Okay, so great, now I know the weight of a box, but I want to know how much it weighs for one crate. So I need to take my answer I just solved. I did the math in order to do the math and figure out how much a crate weighs. Since there's 14 boxes inside of one crate, I'm going to take the weight of one box, which is 468 ounces, and multiply that by 14. So let me do that. 468 times 14. All right, so if you were playing along at home, you may have gotten the same answer. I got 6,552. But that's not our total answer. We want to make sure that we say the total weight in ounces. That's our label. And the label, of course, is ultra important. So, oops, if my page didn't mess up there, I'd have 6,552 ounces. And I can just put OZ as my abbreviation for ounces. So again, on number 2, labels are huge. And it tells us right there that we need a label of ounces. So make sure you're doing the math to do the math, and then add your label of ounces. Let's move on to number 3. Number 3 says, Jen makes a rectangular banner. It is 2/5 yards long and 1/5 yard wide. What is the area in square yards of the banner? All right, so let's take a look at it. One of the things that I like to do is draw things out visually. It helps me a little bit to see what I'm looking at, and that's something you can do as well. So let's get to my work here on paper. I'm going to draw out my rectangular banner that Jen has made. There we go. And that might be more square than rectangle, but you get the idea because it's just for visual purposes, doesn't have to be exact. It's 2/5 yards long. Okay, so that's 2/5 yards. And then it's 1/5 yard wide. Okay, and again, people are always asking me like, what is it, do I have to put the width here and length there? Ultimately, it doesn't really matter in your drawing where it is. All we care about is using those numbers to substitute. And we know there's a formula to find the area of a rectangle, and that would be A equals base times height. Now, some of you might know this as length times width, and I will tell you there is no difference. As long as you're using the right numbers when we substitute, then you're in good shape. I think base times height, because there's our base, there's our height. Some people think length times width, which is length times width, same thing. So now we've written the formula. That's our first step. We want to do that every single time. Next up, we want to go ahead and substitute. So the A is what we're trying to find, the area. So I'm going to leave the A there. I can substitute in my base and my height. And again, if you put your numbers in differently than I'm putting them in, or different from your neighbor, it doesn't mean you're going to be wrong because we're multiplying these numbers, so they can be switched around. So I'm just going to go, my base is 1/5 times my height, which is 2/5. Okay? And now to find the area, I just multiply. If we're multiplying fractions, we don't need to worry about common denominators, common numerators, anything like that, because we just multiply straight across. So that's one really nice thing about multiplying fractions. So in that case, I have 1 times 2, just the numerators. 1 times 2 is 2. Then I have my denominators, 5 times 5. 5 times 5 is 25. Now I always want to look at a fraction just to make sure that it is simplified. And in this case, 2/25 is as simple as we can go. Okay, I'm not able to divide those by the same number in any case. So 2/25 is my final answer, but I want to make sure I put a label on there. And if I look back at the question, it does say, what is the area in square yards of the banner? Now knowing that, it tells me right there what my label should be. So I can write yards squared. I can write square yards. Somehow, some way I'm going to indicate that it is square yards. So it's 2/25 square yards. Again, the formula base times height equals area is going to be huge to know for this week's focus. Let's take a look at number 4. Now number 4 is a multiple answer question. So we want to look at this picture here. It's a composite shape, which means that it's a shape made up of different shapes. In today's case, it appears to be a rectangle and a triangle. So we want to look at all of our options, A, B, C, D, and E, to see which one of these options are true. So first, let's take a look at letter A. Letter A says the composite shape is made up of a rectangle and a right triangle. Well, let's consider for a moment. Do you see the rectangle? I do. It's right there on the bottom. So it does have a rectangle. What about a right triangle? There is a triangle on the top, but you have to ask yourself, is that a right triangle? A right triangle will have at least one 90-degree angle, and I do not see a 90-degree angle in that triangle. So letter A cannot be correct. What about letter B? It says the composite shape is made up of a rectangle and an isosceles triangle. Well, once again, let's take a look at it. We've got our rectangle. We're good there. We already said that in letter A. What about our triangle? Take a look at it. It's an isosceles triangle. Well, you may recall that an isosceles triangle is a triangle that has two sides that are equal. And I always think isosceles, I have two eyes, and my eyes, for the most part, are the same. They're both the same color, same size, shape, and on and on. Isosceles has two sides that are the same. Let's take a look at our triangle. Does it have two sides that are the same? Well, I see one side is 10 feet, one side is 4 feet, and one side is 8 feet. Unfortunately, none of those sides are the same. That makes it, it can't be an isosceles triangle then. So unfortunately, letter B is out. Let's take a look at letter C. The composite shape is made up of a rectangle and a scalene triangle. Well, we've got that rectangle down. We know that from A and B. Let's look at that triangle again and consider a scalene triangle. Now, when I think of a scalene triangle, I kind of hear the word scale in the word. And fish have scales on the outside of their bodies. And one interesting fact is that scales are unique to the fish. Just like fingerprints are unique to individuals, nobody has the same fingerprints as anybody else. The same is true for scales on a fish. So a scalene triangle has unique sides. No sides are the same, just like no scales are the same. So is this a scalene triangle? Let's examine it one more time. One side is 8 feet, one side is 10 feet, one side is 4 feet. Is that a scalene triangle? Yes, it is. None of the sides are the same. So we finally have an answer, and that would be letter C. Let's take a look at letter D. It says to find the perimeter of the composite shape, you need to add the lengths of 6 sides. Well, for this one, we might have to consider what perimeter is. Perimeter is the measure of the outside of a shape. Remember, this composite shape is made up of a triangle and a rectangle. The outside of that shape would just be the outside edges, not the side that cuts through the middle. So let's count up the sides of the shape and see if there are 6 sides. So I have 1, 2, 3, 4, 5. 5 sides to my shape. Do I need to add up 6 sides to find the perimeter? No. If I add 6, I'd be adding that line that cuts through the middle, and I don't need that for the perimeter. So unfortunately, letter D is out. How about letter E? Now they give us some actual numbers to look at. To find the perimeter of the composite shape, you could use this expression, 6 plus 10 plus 6 plus 8 plus 4. Whew, that's a lot of numbers and kind of hard to keep straight. You may want to write this down on your paper and maybe make little notes or check off the numbers as you see them. That way you're making sure that you've got them all, you're not missing some or adding some in that you don't need. So I have 6 feet, 10 feet, 6 feet, 8 feet, and 4 feet. it looks like letter E would help me to find the perimeter because all of my sides are there, all 5 of them. Letter E is one of my answers. And finally, let's take a look at letter F. To find the perimeter of the composite shape, you could use this expression, 6 plus 10 plus 6 plus 10 plus 8 plus 4. Well, take a look at it. We have 6 and 10 and 6 and 8 and 4, but not that extra 10. The extra 10 is the line that cuts through the middle, which we do not need as a part of our perimeter. So there you have it. It's a quick look at our focus for day 2. Please feel free to review this as often as necessary and share it with parents, brothers, sisters, grandparents, anybody who wants to see it. But for the most part, it's going to be important that you make sure that you understand how you do focus so you're best prepared for our quiz coming up later this week. That's all for today's edition of The Aftermath. I'm Mr. Regner. Have a wonderful day.
Math, aftermath, it's the aftermath. Aftermath, it's the aftermath. Math class is fun, but when it's done, stay in the zone. On your own, it's math review, made just for you. Take a video wherever you go. Aftermath, it's the aftermath. Aftermath, it's the aftermath. Oh yeah.